Yes, hello dear students. Today's class we are starting with the next part of syllabus of electrostatic potential and capacitance. So, ಇವತ್ತಿನ ಕ್ಲಾಸ್ನಲ್ಲಿ ನಾವು ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಆ್ಯಂಡ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಅನ್ನೋ ಚಾಪ್ಟರ್ನ ಮುಂದುವರೆದ ಭಾಗವನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ವಿಡಿಯೋ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ನಾವೆಲ್ಲ ಹತ್ರನೂ ಕೇಳ್ಕೊಳ್ಳೋದೇನೆಂದ್ರೆ, ಯಾರ್ಯಾರು ನನ್ನ ವಿಡಿಯೋನ ಹೊಸದಾಗಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ ದಯವಿಟ್ಟು ನಮ್ಮ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ರಿ. ಆಮೇಲೆ ವಿಡಿಯೋನ ಲೈಕ್ ಮಾಡಿರಿ ನಿಮ್ಗೆ ಇಷ್ಟ ಆದರೆ, ಮತ್ತು ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆಗೆಲ್ಲ ಶೇರ್ ಮಾಡ್ಕೊಳ್ರಿ. ನಿಮಗೇನಾದರೂ ಈ ಟಾಪಿಕ್ ರಿಲೇಟೆಡ್ ಡೌಟ್ಸ್ ಇತ್ತಂತಂದ್ರೆ ನೀವು ಕಮೆಂಟ್ ಮೂಲಕ ನನಗೆ ನಿಮ್ಮ ಡೌಟ್ಸ್ನ ಕೇಳ್ಕೊಬೋದು, ಆಯಿತಾ? ಓಕೆ, ಸೊ ಕಮಿಂಗ್ ಟು ದ ಸಿಲೆಬಸ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದ ಟು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಹಿಯರ್. ನಿಮ್ಮ ಸಿಲೆಬಸ್ಗೆ ಇರೋದು ಈ ಎರಡು ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ನೀವು ಮೆನ್ಷನ್ ಮಾತ್ರ ಮಾಡಬೇಕು. ಅಂದರೆ ನೀವು ಎಕ್ಸಾಮ್ನಲ್ಲಿ ಈ ಎರಡು ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ನ 1 ಮಾರ್ಕ್ಸಿಗೆ ಅಥವಾ 2 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ. ಅಂದರೆ ಡೆರಿವೇಷನ್ಸ್ ಇರೋದಿಲ್ಲ, ಜಸ್ಟ್ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ನ ನೀವು ನೆನ್ಪಿಟ್ಕೊಂಡು ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ನಲ್ಲಿ ಬರುವಂಥ ಟರ್ಮ್ಸ್ನ ಬರೀಬೇಕು. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಯಾವುದಂತಂದ್ರೆ ಮೆನ್ಷನ್ ಆಫ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ಆ್ಯನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಇನ್ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. So what is the equation for that? U of theta is equal to minus PE cos theta, or if theta is equal to 0, then this will be equal to minus P bar dot E bar, where E is nothing but the electric field and P is the dipole moment. ಇದನ್ನು ಯಾವ ರೀತಿ ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮ್ನಾಗ ಅಂದ್ರೆ, ರೈಟ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಇನ್ ಆಫ್ ಆ್ಯನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಇನ್ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಅವಾಗ ನೀವು ಈ ಈಕ್ವೇಷನ್ನ ಬರೋದು ಇದರಲ್ಲಿರುವಂಥ ಟರ್ಮ್ಸ್ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ಗೆ 1 ಮಾರ್ಕ್ಸು, ಇಲ್ಲಿರುವಂಥ ಟರ್ಮ್ಸ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ಗೆ 1 ಮಾರ್ಕ್ ಆದರೆ 2 ಮಾರ್ಕ್ಸ್ನ ಈ ಥರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತಾರೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಸೊ ಸೆಕೆಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಈಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ electric potential energy of a system of 2 point charges in the presence of external electric field. Potential energy is equal to Q1 V R1 bar plus Q2 V R2 bar plus 1 by 4 pi epsilon naught Q1 Q2 by R1. Okay, ಇಲ್ಲಿ ಟರ್ಮ್ಸ್ ಯಾವ ಬರ್ತಾವೆ ಅಂದರೆ Q1 is nothing but the charge of first particle, Q2 is the charge of the second particle. We can say R1 is the distance of the particle Q1, R2 is the distance of the particle Q2, and V is nothing but the electric potential. Okay, so these two expressions you are having, just the mention of expression, no need of derivations for these two equations. The next topic you are going to study about is the dielectrics and electric polarization. So what are dielectrics? Dielectrics are the non-conducting substances. Such substances we call them as dielectrics. The non-conducting substances are called as dielectrics, right? So there are two types of dielectric substances. One is the polar dielectrics or the polar molecules, we can say, right? The second one is non-polar dielectrics or non-polar molecules. What are polar molecules or polar dielectrics? These are the molecules in which the positive and negative charges, the positive and negative charges do not coincide. Such substances or such dielectrics are called as polar molecules, right? Coming to non-polar molecules, the molecules in which positive and negative charges coincide. Such molecules are called as non-polar molecules. Right. The second difference is these have permanent dipole moment. Permanent dipole moment. Permanent dipole moment. Non-polar molecules, these do not have permanent dipole moment. Permanent dipole moment. Right? So what are the examples for polar and non-polar molecules? For polar molecules, we are having the examples as H2O, right? Athwa HCl and N2O. Okay. What are the examples of non-polar molecules? H2, N2, O2, CO2 and many more. So these are the differences between polar molecules and non-polar molecules. Dielectrics are the non-conducting substances, right? These are of two types. One is the polar dielectric or the polar molecules. Another one is non-polar molecules or non-polar dielectrics. What are the differences between polar and non-polar molecules? The very first difference between these two is the molecules in which the positive and negative charges do not coincide, right? The molecules in which positive and negative charges coincide, those are called as non-polar molecules. The second difference is the polar molecules have permanent dipole moment. For example, water, hydrogen chloride, athwa N2O. These are the examples of. The second difference for non-polar molecules is these do not have permanent dipole moment. For example, H2, N2, O2, athwa carbon dioxide. So these are the examples and differences between polar molecules and non-polar molecules. Next we are going to study what is the behavior of the polar molecules and non-polar molecules in the presence and absence of external electric field. The behavior of polar molecules in the presence of external electric field. Say for example, if you consider a dielectric medium having different molecules of different dipole moments, in the absence of electric field, the dipole moment of different molecules, they will be randomly arranged due to thermal agitation. So the net dipole moment here in the absence of external electric field will be 0. Coming to the presence of external electric field. In the presence of external electric field, the dipole moment of different molecules, they will be aligning in the direction of applied field. The different molecules, they come and align in the direction of the external electric field. Now the dielectric is said to be polarized. This dielectric is said to be polarized, and the reduction of electric field takes place within this dielectric. This is how the behavior of the polar molecules is shown in the presence of and absence of electric field, in the absence and in the presence of the external electric field. Coming to the behavior of non-polar molecules. The non-polar molecules in the presence and absence of the external electric field. In the absence of external electric field, the dipole moment is 0. In the absence of external electric field, the net dipole moment in case of non-polar molecules, it will be 0. Okay. When we apply an external electric field in a molecule, the negative charges and the positive charge will be displaced. They will get separated and move away from each other. Due to this, they move in the opposite directions. Due to this, the system is said to be polarized. The dielectric system is said to be polarized. Okay. So So this is about the behavior of polar molecules and non-polar molecules in the presence and absence of the external electric field.